Hello everyone, and welcome to another video in my channel. In this video, I am required to find the value of x given that e raised to the power x squared minus 1 is equal to x. I have a fine combination of an exponential function and a linear function forming an equation. What am I going to do to solve this? When we look at this, we will see that this is difference of two squares. But if we go by that, the method will be a bit cumbersome. So I'm going to do this. I am going to rewrite the equation to be in this form. X times e raised to the power x equals to a constant. When I have this, I can take the lambda w of both sides. So if I take w here, x times e raised to the power x equals to w here times k. Now here we simplify into x equals to w times the constant. So I need to rewrite this to be in this form so I can take the lambda w of both sides. This is how I'll go about it. I'll first of all write the equation e raised to the power x squared minus 1 equals to x. Now I'll apply a law in indices here, that is the subtraction law of indices. If I have a raised to the power b minus c, it is the same thing as a raised to the power b divided by a raised to the power c. So this law will be applied here. It now becomes e raised to the power x squared times e raised to the power minus 1, because this is also 1 over e raised to the power 1 equals to x. The next thing I will do is to divide both sides by e raised to the power x squared. So if I divide this by e raised to the power x squared, I will divide this by e raised to the power x squared because this is an equation. This and this will cancel out, leaving us with x times e raised to the power minus x squared equals to e raised to the power minus 1. So this is the same thing as this. Now it is gradually taking this form that I introduced earlier. Now the problem is this part, which is the minus x squared. To solve this problem, let us square both sides. If we square both sides, we'll have x times e raised to the power minus x squared squared is equal to e raised to the power minus 1 all squared. Now, if we apply this property of indices, which is a times b all raised to the power 2, let's use another letter here, c. It is the same thing as a raised to the power c times b raised to the power c. So I'll apply this property here. This becomes x squared times e raised to the power minus 2x squared is equal to e raised to the power minus 2. Good. All we now need to do to make this to be exactly this is to multiply both sides by minus 2. So that becomes minus 2x squared times e raised to the power minus 2x squared equals to minus 2 times e raised to the power minus 2. Good. So I can comfortably take the w of both sides. So we see this and this are exactly the same. So when we take w of this side, here becomes minus 2x squared according to this property. We see it here reduces or simplifies into this. So this simplifies into this equals to w times minus 2e minus 2. This is a constant and the value is w times minus 0.27067. Good. So I have minus 2x squared equals to this. When I find the w of this side, I had minus 1.999 or minus 0.4064. Great. So minus 2x squared equals to this. I can write this one as a whole number, that is minus 2, or here becomes minus 0. The same thing, 4064 minus 2x squared. So I need to divide both sides by minus 2. X squared will now be 1 or minus 0.203225. Not minus, please, because I am dividing both sides by minus. So here will be plus. So x equals to the square root of 1 or x equals to the square root of 0.203225. X equals to 1 or x equals to 0.45. When we substitute 1 into the original equation where we have x, we are going to get a balanced equation. So x equals to 1 or x equals to 0.45. If we also do the same thing here, we are going to get a balanced equation. Thanks for watching. See you in another video.